We are opening. Yes. You are waiting for the sound to stop. First, tap the GB button once and then let it go. Okay. The detector is now ready to differentiate. The head should be approximately 5 centimeters from the ground. You bring it closer to the level where it will remain. Like this. Yes, there is no metal at the moment. Under normal circumstances, if you hear a sound when you bring the head closer, you move it around on the ground. If you find a metal, the sound will end after you leave the spot where it reacted. So you will confirm that there is a metal here. You will try to adjust the ground setting a little on the side. Right now, it doesn't require any ground setting. What do we need to do? We need to achieve a slightly higher performance. We need to conduct a deeper search. In fact, these settings are ideal. This system has a sensitivity of perception that adequately addresses the needs of a user, yet we will try to increase our sensitivity as much as the conditions and environment allow us to. We will strive for deeper understanding. Now, regarding the sensitivity issue, the detector has two components that are of interest: sensitivity and gain. To the sensitivity search title, and this signal strength sent to the search coil. The signal strength sent to the search title charges the magnetic field over the metal found in the ground. As for gain, inside the soil, on the metal created, it depends on how accurately we want to sense the magnetic effect. We can refer to one as the sender and the other as the receiver sensitivity. Better. You understand. The third part is GND mode, automatic ground adjustment speed. The detector has an automatic ground adjustment speed. Thus, even in the most challenging ground conditions, by calibrating properly to prevent misunderstandings, will not allow it. A minimum of 1.9, fastest ground adjustment. It operates with the ability to do so. Thus, when you lower the title towards the ground, it is capable of executing automatic alignment. The fourth section labeled mode. It lets you switch search modes. There are 4 modes available. The first mode is the general search mode that allows us to conduct searches comfortably even in electrical environments that provide slow search capability. The second mode is away from electrical environments and has a fast search and deeper search method where even small objects can be detected. The third mode is used with detector heads for 3-dimensional scanning. This is the search mode. It allows for detecting empty spaces. The fourth mode is detected, a separate section where the depth of metal objects can be calculated. Here, the detected target's diameter, which we determine by approaching from around, is entered into the appropriate section of the fourth mode to see the detected target's average depth that we can view in a separate section. We are currently in the first mode. This general search meets all the user's needs in every kind of environment. Search inquiry mode. What action should we take at this moment? The detectors. We will try to increase sensitivity and perceive more deeply. For this, you will press the menu button once. Here. Sensor. Other. Because our camera's battery is dead from the phone. We will continue recording video. We apologize for the inconvenience. Now, the detectors sense part. Let's slowly increase the transmitter sensitivity. First, we press the menu button. After the marker below appears, we slowly increase it. It's now 6. Let's continue. It's now 7. Let's continue. 8 is ideal. Now we press the menu button again and we will increase our receiver sensitivity. We press gently. 7. 8 is ideal. Now this detector, when used with a 35 centimeter head, the detection power will be lower compared to other heads and will be less affected by surrounding electrical interference. This gain sensitivity. Electromagnetic noise caused by environmental factors while making changes in the sections, should it result in interference and distorted sounds in the detector, the sensitivity should be reduced to a certain level as permitted by environmental factors. We need to drop it. In fact, the most ideal electrical regions to seek is taking place at the factory settings. However, a user too, he aims to search with high accuracy in the area he is in and where he will search. So, these sensitivity settings can be adjusted by the user. The place he will look into, to the extent permitted, by increasing to the starting point of electromagnetic interference, it can perform a search. Now, we made an adjustment and we can start searching slowly using the sweeping method, 5 to 10 centimeters from the ground. Distance from the ground. Each step forward should be the length of a coil so that don't miss anything that is on the ground. Now we are slowly approaching the target. Yes, as you can tell from the sound, we are performing a detection. Now, perception is identified when we feel it. Materials, exact center point, needs to be understood. Therefore, scanning method plus sweeping method for the central point, we should use it. Now, from the opposite direction, we need to determine the central point by passing through the target. Now we found this direction. Also, by coming from the other direction, central location. It became clear. Now we will move away from the target. The heading will be brought closer to the ground, and we will slowly approach the target, a bit faster because it will align. Approached, okay? We approached a bit too slowly. Now, to the left. We are coming slowly. Okay, because it fully identified the metal. All right, now from this side too. We are coming from the wrong place. Okay, like this. Let's come from this side. We'll find the distance from the other direction too. All right. For example, let's come from the other opposite direction now. Okay, this is our distance like this, approximately. The distance we determined is about 20 centimeters by 12 centimeters. Target size we have set. We need to take the average of this, between 12 and 20 centimeters approximately. It will correspond to a diameter of 16 centimeters. Now, let's mark the fourth section from the menu below. Let's come this far. Press the GB button. When you reach the fourth section, you will continue. Press. Press again. Now it's progressing here. Press. 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 1. More. Okay. That's enough. Now it's blinking. We will wait for it to stop. Okay. When our writings appear normally on the screen. Now we are raising the search title up, and towards the target center we have determined we are approaching. Get as close as possible. You can lean it. And on the screen, we can calculate the depth in centimeters at the same size. We can calculate. Thus, we can understand the depth of the detected target. Again with the sweeping method. It was already indicating to us that it was metal by making a cut in the sound. Okay, now did it come right over me? Just step back, wait a moment, go over it again. Detector, reset the perception. Go over the target again, but cross over the target and render it void. Allow a second to elapse, then cross over it once more for definition. Now here, it creates a dilemma in perception. It indicates that there is an unwanted metal. When it gets a little closer, the sound will cut off completely. It indicates to us that it is iron. If this were a precious metal, this sound would be regular. It would achieve a continuous rise. Now, let's pass over it from the other side, from the other pole. In this way, the detected metal is about. We can gain information. Is the metal valuable? Is it worthless? What level of conductivity does it have? How deep? Search operation. It will give more information. The 35 centimeter search head has a maximum reach of 1.5 meters. The ideal can be searched for up to a distance of 1 meter. And it numerically indicates the conductivity level of metals as well as DD. Because it is equipped with, it informs whether the metals contain iron or not, alerts the user. Initially, this information is sufficient for a user to search. The environmental factors required. Usage details are also. The user can search in the desired areas over time. By adapting itself for superior performance, it can exhibit and conduct deeper searches, as it can provide. We can cut the video here.